What specific problem does the proposed method aim to solve?
The proposed method aims to solve the problem of increasing a product's visibility and chances of being listed as a top recommendation in a large language model, LLM-driven search framework. By inserting a strategic text sequence, STS, into a product's information page, vendors can manipulate the LLM's recommendations in favor of their target product. The framework leverages adversarial attack algorithms to optimize the STS, making the target product more likely to be recommended to potential customers. This method addresses the challenge of influencing LLM search responses to gain a competitive advantage in e-commerce by strategically enhancing the visibility and ranking of specific products.
How does the proposed method or algorithm work? Illustrate step by step.
The proposed method works by manipulating a large language model, LLM, to increase the visibility of a target product in its recommendations. The algorithm involves inserting a strategic text sequence, STS, into the product's information, which is optimized using the Greedy Coordinate Gradient, GCG algorithm. The STS is strategically placed in the product details to influence the LLM's recommendation towards the target product. The process begins with a user query, prompting the system to extract relevant product information from a knowledge base. The extracted information and the query are concatenated and fed into the LLM to generate a response. The STS is initialized with dummy tokens and iteratively optimized by replacing tokens with the highest gradients. The STS is designed to minimize the LLM output's cross-entropy loss with respect to a specific string related to the target product. By optimizing the STS, the LLM is influenced to recommend the target product more prominently, even if it may not align with the user's criteria. The impact of the STS on the product's ranking and visibility is evaluated through multiple iterations, demonstrating how the STS can significantly affect the product's position in the recommendations. Additionally, the robustness of the STS to variations in product ordering is tested by randomizing the product list in each evaluation, showing how the optimized STS can maintain its advantage across different scenarios.
What are the theoretical or practical benefits of using this method?
The theoretical and practical benefits of using the method described in the paper include the ability to manipulate large language models, LLMs, to increase the visibility and recommendation of specific products, thereby potentially influencing consumer choices and increasing sales for vendors. The framework developed in the study allows for the insertion of a strategic text sequence, STS, into a product's information, optimizing it using algorithms like the Greedy Coordinate Gradient, GCG algorithm, to enhance the product's ranking in LLM recommendations. This method offers vendors a competitive advantage by strategically influencing the LLM's responses, potentially leading to increased product visibility and sales. Additionally, the study demonstrates the robustness of the STS to variations in product order, ensuring consistent performance in real-world LLM-driven search tools. The approach explored in the paper provides insights into how AI-driven search tools can be leveraged for business and e-commerce purposes, highlighting the potential impact on market dynamics and competition. Furthermore, the method offers a novel application of adversarial attack algorithms for benign objectives, showcasing the versatility of such techniques beyond traditional malicious uses. Overall, the method presents a unique and innovative way for vendors to optimize product visibility and recommendations in the digital marketplace using LLMs.
How is the method validated or tested?
The method is validated and tested through a series of experiments using the large language model, LLM, called LLAMA2. The researchers develop a framework to manipulate the LLM's recommendations in favor of a target product by inserting a strategic text sequence, STS, into the product's information. They optimize the STS using the Greedy Coordinate Gradient, GCG algorithm, to influence the LLM's output. The impact of the STS on the LLM's ranking of two target products, Cold Brew Master and Quick Brew Express, is studied. The researchers conduct 200 independent evaluations of the LLM, with and without the STS, to observe the changes in the product rankings. They also test the robustness of the STS by randomizing the order of products in the LLM's input prompt and evaluating its effect on the target product's ranking. The results are analyzed to determine the advantage, disadvantage, or neutrality of adding the STS to the product information. Additionally, the researchers optimize the STS to be robust to variations in product ordering, further testing its effectiveness in influencing the LLM's recommendations. Through these experiments and analyses, the researchers validate the method by demonstrating how the STS can significantly impact the visibility and ranking of target products in the LLM's recommendations, providing a competitive advantage for vendors in e-commerce scenarios.
What results were achieved with this new method?
The new method achieved significant results in manipulating large language models, LLMs, to increase the visibility and recommendation of target products. By inserting a strategic text sequence, STS, into the product information, the LLM's recommendations were influenced in favor of the target product. The STS optimization using the Greedy Coordinate Gradient (GCG) algorithm improved the rank of the target products, Cold Brew Master and Quick Brew Express, in the LLM's recommendations. For Cold Brew Master, the STS elevated the product to the top recommendation, even though it was initially not recommended due to its high price. The STS also notably increased the visibility of Quick Brew Express, positioning it as the top recommendation from being the second recommendation without the STS. The STS was shown to be robust to variations in the order of product listings, further enhancing its advantage in influencing the LLM's recommendations. The method demonstrated that even for products close to the top of the recommendation list, the STS had a substantial impact on the product's ranking and visibility, providing a competitive edge for vendors in e-commerce platforms.
What are the limitations or drawbacks of the method?
The limitations or drawbacks of the method outlined in the paper include the potential ethical concerns surrounding the manipulation of large language models, LLMs, for commercial gain. By inserting strategic text sequences, STS, into product information to influence LLM recommendations, there is a risk of creating a biased and unfair online marketplace where products are promoted based on manipulation rather than genuine merit. This could lead to a distortion of competition and consumer choice, as products may be recommended not based on their actual relevance or quality, but due to the inserted STS. Additionally, there is a concern about the transparency and trustworthiness of the recommendations provided by LLMs if they can be easily manipulated by vendors. This could erode consumer confidence in online product recommendations and the integrity of e-commerce platforms. Furthermore, the method's reliance on adversarial attack algorithms, such as the Greedy Coordinate Gradient (GCG) algorithm, raises questions about the potential misuse of such techniques for purposes other than enhancing product visibility, highlighting the need for ethical guidelines and safeguards in the use of LLM manipulation for commercial purposes.